Okay, the goal of this lesson is to learn how to graph logarithmic functions. If you remember from last class, a logarithmic function is a function that is the inverse of the exponential of the same base. So, for example, this log base 3 of x is the opposite of the exponential function 3 to the x. Now, in order to graph this function, we are going to need to take a look at the inverse, because actually graphing the log function is not a simple task. So what we're going to do is first identify the inverse of f of x, and we're going to call it g of x. Now, if we remember from last class, to get the inverse, we simply write an exponential function with the exact same base. So we know then that the inverse of log base 3 of x is g of x equals 3 to the x. If you don't remember this, please take a look at your notes from last class. Now, we learned over the last couple of weeks how to make tables and graphs for exponential functions. So what we're going to do is create an xy table that will give us the values for this function. And if you also remember from last class, we like to choose easy numbers, like -2, -1, 0, 1, and 2. Now go ahead and grab a calculator and test each of the values. Let's go ahead and let's start with 3 to the -2nd power. So we're going to type in 3 to the power of -2. And as you can see, we get 0.111. So we're going to write here 0.1. Now that's not the exact answer, but that's okay. We're going to change the -2 to a -1. And we get 0.3. Change it to a 0, we get 1. Change it to a 1, and we get 3. And then change it to 3 to the 2nd power, and we get 9. Now, once we have all these values, we're actually able to use this table to create a table for our inverse function. If you remember from before, an inverse function is a function whose x and y values reverse for the function. So if we take a look here, these x values will become the inverse function's y values, and these y values will become the inverse function's x values. So we are literally going to take each of these, and we are going to reverse their places. And these points that we're writing here on the table, these are going to be for our log base 3 of x. Now we're going to go ahead and we're just going to graph those points. We're actually going to graph both functions, as you can see here, f of x and g of x. I recommend you use 2 different colors just so that you can see the distinction between the two graphs. I'm going to go ahead and graph g of x in green. So if you can see here, our first point is -2, 0.1. So I'm going to go left 2 and up about 0.1. And then my next point is -1, 0.3. So I'm going to go left 1 and about 0.3. Now none of these points are going to be exactly precise, but we're going to try to get as close as we can. 0, 1, 1, 3, and 2, 9. And then we're going to connect these with a nice, smooth curve. And this is definitely exponential growth, right? Because if we go from left to right, we see that this grows quite quickly. Now I'm going to grab a different color, and we're going to grab our actual f of x, our log function. And so you'll notice that the x values are what used to be the y values. So we have to pay attention to what we're doing here. So we're going to go to 0.1, and then we're going to go down 2. We're going to go to 0.3, down 1. We're going to go to 1, 0, 3, 1, and 9, 2. And you're going to notice something very nice here. You're going to notice, once you connect this, that these are in fact inverses. And if you remember from our previous lessons on inverses, we know that things are inverses if they perfectly reflect over this line, this y equals x. And so what you see here is the graph of f of x and its inverse g of x, the exponential. Now, the last thing we need to do here is we need to be able to identify what's called the asymptote. Now, an asymptote is just a line that your function never crosses. Now, if we look at our g of x here, you'll notice that our g of x goes up, 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 up to infinity. But if we read our graph to the left, we'll notice that it doesn't actually go down to infinity. It goes down closer and closer and closer and closer to this x-axis here. Now, this x-axis is actually referred to as the line y equals 0, because that is where we cross actually at 0 on the y-axis. So we're going to say here that our function g of x has an asymptote at y equals 0. And all that means is that this line here, this curve, will never cross y equals 0. It'll get infinitely close, but never touch. Now, if you take a look over here at f of x, it actually passes that y equals 0. However, if we go to the left, it gets closer and closer to x equals 0, but never actually crosses. So it will never cross this y-axis. And this y-axis line is our other asymptote. So this one here is what we call x equals 0. And we're going to say here then that our function, our log function, f of x, has an asymptote. Remember, that just means a line it doesn't cross at x equals 0. Now, this is super useful because then what you're going to notice is that whenever you have an exponential function, it has what we call a horizontal asymptote. And whenever we have a log function, it has what we call a vertical asymptote. So up and down for log or natural log. Okay, now that you've seen the first example, go ahead and complete parts B through D, and then please compare with a neighbor, and you're welcome to check your answers on Desmos. Then upload it on Canvas. We do have a quiz tomorrow. Have fun working on this.